Good morning, everyone. Myself, Monica Nancy Priya, in the Department of Electrical and Electronics Engineering. In this semester, I'm handling basic electrical and electronics engineering in the subject code EE25C01 in the regulation 2025. Today, we are going to study one of the most important power electronic devices called silicon control rectifier. It's commonly known as SCR. So, SCR is widely used in power control applications such as motor speed control, battery chargers, controller rectifiers, inverters and industrial power systems. So by the end of the session, definitely you will understand what is SCR, the construction of SCR, working principle, operating modes, characteristics, and the advantages, applications, and limitations. So first, what is the introduction? What is silicon control rectifier? So the SCR stands for the silicon control rectifier. So it is a semiconductor switching device belonging to the thyristor family, and the SCR is called a control rectifier because the diode conducts automatically when it is a forward bias, and SCR conducts only when it receives the triggering signal at gate terminal, so that we can control when current starts flowing. So the key points, what are the key points of this? It is a three-terminal device. So it's a three-terminal device, and it is a four-layer semiconductor structure, and it have a unidirectional current flow. Then it is not a bidirectional current flow. It is a unidirectional current flow, and it is used for the power control. So, for example, think of a SCR as a gate at a railway crossing. Okay, so the train means it's a current. So current cannot pass through until the gate is open. Similarly, the current cannot flow through the SCR until a gate signal is applied. So whenever the gate signal is applied, the current will flow. So why SCR is called a control rectifier? Because conduction can be controlled through the gate terminal. Next one is, what is SCR? So SCR is a four-layer semiconductor device having three terminals, that is anode, cathode, and gate. So what are the terminal functions? Anode is a positive terminal, and the current enters through the anode. Okay, this is the positive terminal, so the current enters through the anode, and the cathode is a negative terminal. The current leaves through the cathode. This is the symbol of the SCR. This is the layers having a three terminals. Okay, so what is the gate? What is gate? The gate means it's a control terminal used to trigger the SCR. So if we want to trigger something, so we have to trigger the gate. So the gate does not carry the main load current. Okay, its purpose is only to switch on the SCR. So gate act like a remote control. Okay, what the remote control do for a car? If we turn left, it turns left. If we turn right, it turns right. So the small gate current controls the large anode current. Next one is the SCR construction. So the SCR consists of four layers, that is PN, PN or NP, NP. That is the two types of SCR. One is PN, PN, that is NPN, NPN. Next is the forming a three junction, that is J1, J2, J3. This is a junction. The J1 is in between the P1 and N1, J2 is in between the N1 and P2, J3 is in between the N2 and P2. So we are having the three junctions, and the terminal connection is anode, that is connected to the P layer, cathode, that is connected to the N layer, and the gate is connected to the P layer. Okay, so we are having the three terminal connections. And the next one is the doping. What is the doping means? It is the heavily doped layers and the lightly doped layers. So the outer layers are heavily doped. So the outer layers are heavily doped because it have a better conductivity, reduced resistance, and it's have the lightly doped layers. The middle layer or the lightly doped. The outer layer is the heavily doped, and the inner layer is the lightly doped. That is better conductivity and proper control action and efficient switching, because the gate is connected to the middle layer, so that is lightly doped layer, so it is the efficient in switching. So what then the important one is, it contains the four alternating semiconductor layers. Okay, next one is the working of SCR. First, what SCR works? How does the SCR works? The basic condition is anode must be positive with respect to cathode. Then the load is connected in series with the Yes, yeah. So we are having the three modes. One is the forward blocking mode, forward conduction mode, and the reverse blocking mode. So understanding these three mode is the key to understanding the SCR. Next one is the forward blocking mode. This is the forward blocking mode diagram. The condition is anode is positive and the cathode is negative. So the gate kept open. So there is a no current flows in between the gate. So the junction biasing is J1, J2, J3. So J1 is the forward bias and the J2 is the reverse bias and the J3 is the forward bias. Okay. So what is the result? The J2 prevents the current flow because there is no gate signal is gate gets open, so there is no voltage across the gate. So only a very small leakage current flows. So the ACR behaves as the open switch. Next one is the if we have an example like a water valve. So the pressure is available, but valve remains closed. So there is no water flows on that. Next one is the forward conduction mode. Here the SCR turns on when we apply positive gate pulse. If we apply the positive gate pulse in the gate, that is the middle layer, increase the anode voltage above the breakover voltage. So in first method is apply the gate pulse and the second method is increase the anode voltage above the breakover voltage. Then what happens? The J2, this junction breaks down. So if the junction breaks down, the SCR starts conducting. So the current flows from anode to cathode. So whatever the junction breaks up, if we are having the two methods, that is the gate is kept open or the anode voltage above the breaker voltage, and so the junction 2 gets breaks down, then the current flows from the anode to cathode. So the characteristic is very low resistance and it having a high current because there is a break down the junction. No, so they act as a closed switch. So the important is once the SCR turns on and removing the gate signal will not turn it off. Okay, so it can be easily understand for the study. Next one is the reverse blocking mode. In this reverse blocking mode, the condition is the cathode is positive and the anode is negative. The gate kept open. So what happened? This negative to positive, the current flows. No. So the J1, where is the J1? This is the J1 is the reverse bias and the J3 is the reverse bias and the J2 get a forward bias. So there is no conduction happens, only the small leakage of current flows. Then the SCR behaves like a open switch because there is no current flow, there is no gate pulse is given. So the SCR behaves as an open switch. So the SCR blocks current in reverse direction. Therefore, the SCR is a unidirectional device. This is very important in SCR. The SCR will have the reverse blocking region means having the reverse voltage applied. There is a tiny leakage current will be there. In forward blocking region also forward voltage applied. There is no gate pulse and the very small current flows through the anode to cathode. Wherever the breakover region occurs, the voltage breaks the breakover value. That is the J2 junction will get breakdown. And the forward conduction region, the switch SCR switches on and the current rises sharply. So the in breakover voltage, minimum forward voltage required to turn on the SCR without the gate pulse. So the importance of SCR is also why SCR is so popular, why we are using the SCR is a common apparatus that is handles the high power. It can withstand the high voltage and high current. So and it can be easily triggering. Only a small gate signal is required. No, so we can easily triggering. Next one is the fast switching. That is a very quick response and having the reliable operation. It's used extensively in industry and it's also having a cost effective. That is a low cost compared with many switching devices. So the efficient power control is also applicable. So the excellent for AC power regulation. So the next one is the application of SCR. That is in electronic switching, the SCR acts as a on-off switch. So it is used in the power control circuits. The next one is the controlled rectifiers. It converts AC to the controlled DC and it is used in the DC drives, industrial equipment, inverters also. Inverter, what the inverter do? It converts DC to AC. So it is also used in the UPS system. Next one is the battery charges. That is the controls charging current and prevents overcharging. Next one is the voltage regulator. It maintains a stable voltage. The power control systems that control power supply to the loads, electric heaters, industrial furnace. Then the surge protection that protects the circuit against the voltage spikes. So the real life example is the fan speed controller, light dimmer, battery chargers, UPS system. Here all the SCR will be used. Next, the disadvantage of the SCR is the main thing is it's a unidirectional device because the current flows only in one direction. They cannot conduct in the reverse direction also. Next one is a positive gate trigger needed. Negative gate current cannot trigger the SCR. So re-triggering AC cycle. That is for every AC cycle, the SCR must be triggered again. And the high frequency limitation. It's not suitable for the very high frequency applications. So every device have the advantages and limitation. But SCR is excellent for the power control, but not ideal for the high frequency switching. So if we have the summarizing this topic is SCR is a four-layer PNPN device and it has a three terminals anode, cathode and gate and it operates in how many mode? Three modes. Yes, forward blocking, forward conduction, and reverse blocking. So the gate pulse is commonly used for the triggering. Once on, SCR remains on even if the gate signal is removed. Okay, so it is widely used in rectifiers, inverters, battery chargers, and the power control circuits. So SCR act mainly as a electronic switch. So these are the topics. These are the main things about the SCR. We'll see the next topic in the next class. These are the references. Thank you.